Birthdays, the day that you were born on. For example, August 2nd, July 16th. Each year after your birth, you will encounter your birthday. But what is a year? On Earth, a year is 365.25 days, the time it takes Earth to orbit around the Sun once. This system is used to calculate the age of everything that is present here on Earth. But what about, let's say, Saturn? One Saturn year is equal to about 29 Earth years because it takes Saturn 29 times longer than Earth to orbit around the Sun. Moving a little further, it takes Uranus 84 years to do the same thing, Neptune 165, and Pluto an astonishing 248. But how long does it take the universe to orbit its star once? Does it even have a star to orbit? How many Earth years is that? Now, to answer this problem, we have to find the length of a year in perspective to the universe. This is where the problem comes in. The universe doesn't have a star to orbit, but it has something to orbit. To understand this, we have to first start from defining the different types of years. A terrestrial year, the year that we're familiar with, is the duration of time it takes Earth to make a full revolution around the Sun. A cosmic year, or galactic year, is the time it takes the Sun to orbit once around the Milky Way galaxy. To put this in perspective, a cosmic year is a full 230 million times longer than a terrestrial year. Now, looking from an even larger scale, does our galaxy, the Milky Way, revolve around anything? The answer is that no, it does not. The reason our Sun orbits the Milky Way galaxy is because of the presence of the supermassive black hole, Sagittarius A, at its center. However, there is no such mass large enough and with a force great enough to attract an entire galaxy to revolve around it. But our story, in fact, does not end here. When you look at the universe as a whole, you can see that it is made up of three different types of things: normal matter, dark matter, and dark energy. Of that composition, normal matter accounts for somewhere between 1 to 10% of all matter. Dark matter accounts for somewhere in the 25% range, while dark energy makes up all the rest, at least theoretically. Out of these three masses, normal matter attracts, dark matter attracts, while dark energy repels. Now imagine two repelling magnets acting against each other, something like a levitating globe. When you spin it, there will be no friction, and the force of the repelling magnets will cause the globe to spin indefinitely. When the Big Bang happened, I can be certain that the forces were not 100% equally spread out, and some places had to have more of a bang than others. This can be thought of as the initial push to get the globe spinning. After that, it's up for the magnets, in this case, the three repelling types of forces, to do the rest of the work, and to keep it spinning around itself. With the expansion of the universe taking place, the outer edges of it are hypothetically orbiting around the center you set for it. So now we just have to find the time it takes for the outer edge to travel the universe's circumference, right? Wrong. Because of this expansion, the length of a year in each point in this universe becomes inconsistent. With the movement of space-time and matter in the universe, the point you set for it no longer becomes fixed, and it will keep changing and changing until one day, in perspective to the outer edge of the universe, a year will never pass. So, when is the universe's birthday? The answer is that it's inconsistent. The three forces acting against one another creates inconsistency, as well as the position of you in space. The location infinitely close to your set center, or the position around the initial form of the universe before the Big Bang, will have already passed infinitely many years, while the position infinitely far from your set center will have not even had its first birthday. I'm Ethan Guan, this is Be the Future. Hope you enjoyed this video, and thanks for watching.